Hi, this is another quick walkthrough of your homework number 2. The reason why I'm trying to emphasize this before we get started. The reason why I'm creating these video walkthrough of your homework is to help those who are not familiar with this type of Excel tasks to get a quick start. Okay, so you should never take advantage of my good intention by just blindly copying the results back into your homework. I can guarantee you that you may fool me for 1 or 2 times, but in long run that will cost you handsomely. Okay, so with that in your mind, please take a look at the rest of the steps. So this homework still uses crime R Excel data. This time I made the rest of the data visible on your end, which is something measured after 10 years. And I also eliminated the crime rate rating because that was something I created ad hoc to assist my previous assignment. So if you look at the assignment question number 1, number 1 is asking you to create a frequency distribution table for the education variable, but this time make sure you include cumulative relative frequency. So again, what I'm going to do is Control A, insert pivot table, and click OK, because the range is correct here, right? Click OK. We are going to summarize crime rate this time. Again, let us group it first. You can just pick a group starting from, let me pick group size of 20, okay, or maybe 15 this time, right? And then let's drop it one more time here and make sure these are counts, okay? And drop it one more time and convert it into the relative frequency. Let's make sure it choose the percentage of grand total. That will show up as a percentage. You drop it one more time. Okay, drop it one more time. This will be the cumulative relative frequency. So here you would choose the percentage running total in crime rate. Okay, this is another name for the cumulative relative frequency as the running total. Okay, running total. So as you can see that this is the running total you're seeing. I think the running total is kind of more descriptive. So we have 3 things ready here. This is frequency. This is relative frequency. And this is going to be cumulative relative frequency. You can just copy this table as is. Copy. And back here as a picture. Okay, so that will help you complete number 1. And number 2, for the crime rate variable, please find out both the median and mean. Okay, so if you look at this assignment, the only variables we're going to use is crime rate after 10 years, and the expenditure year 0. Expenditure at year 0. So probably I can just, it will be more convenient for me to copy these guys. Expenditure here. Just copy these 3 variables and move it to a new worksheet. Okay, so that's going to be more convenient for the homework. So I think question number 2 is asking us to find out the median and mean, right? So what I'm going to do here is mean, median, variance, and standard deviation, and all 3 variables copy. And this time, what I'm going to do here is the transpose here, transpose. Okay, so and then for average, it's going to be average 8 to 8. And median is median 8 to 8. For the variance, make sure you pick S because this is a sample data, 8 to 8. And the standard deviation is STDEV S, 8 to 8. Okay, so I think you need to complete them one by one because we can't really drag and fill which is more convenient usually because the formula is different and range is also different. So what I'm gonna do here is another average A to A. No, it's B to B, right? I should say B to B, not A to A. B to B. And crime rate after 10 years, it's gonna be still average for C to C. And the median for B to B, here's the median for C to C. For the variance, it's called B to B. Variance B to B. Okay, last one. STDV S B to B. STDV S for C to C. Okay. With this completed, I think we're ready to answer this question right here. Both median and mean, are they fairly close to one another? I'm not going to give you the answer, but you can answer the question based on your observation. And why do you think these two are close to each other, and what is the reason that has caused these two are fairly close to each other? Okay, so I explained during the class, it has something to do with extremely large or small values. And then B is about the standard deviation. Please calculate standard deviation without using the Excel formula. Oops, I think we did already use, but if you look at the B, standard deviation again, using Excel formula. So we're good, but all you need to do is now complete the step without using the Excel formula. So I'm pretty sure that I have already demonstrated how to calculate the standard deviation without using the Excel formula. To do that, I think we need to do something here. Okay, let me create some space right after the crime rate. So we need to rely on the average in here. Okay, so what I'm gonna do here is crime rate minus its mean. Remember, we actually needed that quantity first. We need to calculate crime rate minus its mean, which is here 102.80A51, and then make sure you click F4 to do the absolute referencing. Okay, and then what we need is squared value, okay, of the difference. So square it, right? So with these two ready, you can just highlight these two, right? Highlight these two, just highlight these two, and then double click this green dot at the end. Oops, let me do it again. Okay, so this is all the difference, right? This is all the squared difference. So sum of squared, it's gonna be sum C to C, right? This is all I need here. And our variance, of course, is going to be this guy divided by count formula, A to A. So count is going to return us the number of numeric values within a given range. Okay, so because we selected A to A, that means count A to A is going to return the number of numeric values in that given range. So with that, I think we replicated the variance formula. If you're here, oops, there are slight difference here. What is the reason? Okay, remember when we calculated this, we considered this as the sample data. Okay, however, when I did this, I considered this as a population data because I did not do -1 adjustment. So with this adjustment added, you should have exactly the same result here and here. Okay, I hope you get this. And of course, the standard deviation is the square root of the variance, SQRT, of this guy right here. So you have exactly the same standard deviation here. Okay, just report that in your homework. We're done with the number 1 and number 2. And calculate the standard deviation on this variable. What can you comment on the spread of the two variables? So we already obtained standard deviation for, already calculated the standard deviation of crime rate 10 variable using the formula, which is STDVS. So obviously, after 10 years, crime rate has a larger standard deviation. Crime rates has a smaller standard deviation. And what does it mean? And you can just write down your answer based on your understanding about what does standard deviation do. Okay? That kind of concludes number 2. And number 3 is a little bit special, but don't panic. Okay? So using the crime rate variable, please identify an interval, right? You need to identify an interval using the following formula. Okay, look at the formula. The lower bound, the beginning value of this interval is the average minus 2 sample standard deviation. The ending value is the average plus 2 sample standard deviation. So you will have a much smaller value, you will have much larger value there, okay? So what I'm going to do here is I'm going to move on to Excel. I'm going to start something here. Okay, so this is about the crime rate. This is about the crime rate variable. So I'm just going to do it right here. 2s, okay, to indicate this is a 2 standard deviation case. Lower, upper. Okay, this is a lower boundary, this is upper boundary. So lower boundary was calculated using the average, right? Average minus 2 multiply standard deviation. Okay, but the upper boundary is the average plus 2 multiply by the standard deviation. Okay, so we have obtained a section which begins from 45.021979 all the way to 160.59504. This is going to be an interval, okay? So let's take a look from your data how many are actually included within this range. So if you look at it, it looks like nothing is smaller than this lower boundary here, because the lowest value, the smallest value starts from 45.5. Okay, now what about the largest one? 161.8. Okay, so there's only one, it looks like it's outside of this upper bound. So in total, we have one observation out of 47 that is outside of this boundary that we have created using the average and 2 standard deviation before and after. Okay, so fraction inside, okay, is going to be 46, 47. Because I know that this is 47 observations, right? So because previous homework, I know this is 47. So this is going to be the fraction within the 2 standard deviation distance. If you continue to look at the next question, it is actually asking 3 standard deviation distance. Okay, so as you can tell, that it's gonna have a much smaller lower bound and much higher upper bound, because this time we're using 3 sample standard deviation distance. Again, average minus 3 multiply the sample standard deviation here. Again, average plus 3 multiply with sample standard deviation. So this is going to be an interval that is even wider, that actually everything will be, you don't even have to count, right? Fraction within the interval. Did I write that long here? Yeah. So it's going to be even greater. So it's going to be 100%. Everybody is going to be staying within this interval. You may not find, you may be struggling, what is this for, right? But I'm going to talk about this eventually. This is going to be very, very important usage of standard deviation. But I'm just going to let you get exposed before we talk about this intensively. Number 4, use the cross-tabulation technique to summarize the crime rate and expenditure year 0 variable. So this time I'm going to be summarizing the crime rate with expenditure year 0. So let's go back. I think we already have one pivot table created here. So what I'm going to do, instead of this expenditure year, it's going to be dropped to here. And I'm going to do one more time here. So we don't need sum here because I'm doing frequency distribution. So I'm going to do the count again. And also this is way too many values here. So I'm gonna have to reduce that by increasing the size of the group. Okay, so what about increase it to 15? What did I do earlier? Maybe 25, maybe better. Okay, this is fair enough. And then you see all these empty spaces, and if you kind of have a obsession that you don't want to see all these empty spots here and there, there's actually an option you can do. Or right click here, and you can go to the pivot table option, and you can do this. For empty cells, show 0. Only do this when it is appropriate. In our case, this is a frequency, therefore 0 actually means there's no count for that. So that is appropriate, okay? So I'm gonna do is crime rate, and I'm just gonna copy it, put it back here. Okay, so I didn't ask you to describe or comment on this, but as you can see that the lower expenditure is actually, it looks like lower expenditure has, this is expenditure for police, okay? So when your crime rate is low, your expenditure also tend to be low, okay? And then opposite is also true. When you have a high crime rate, your expenditure also tends to be higher. So that is kind of something you can observe by just taking a look at the table. That may or may not be true when we assess that using more rigorous measure, which is numerical measure. But that is the end of the question number 4. And number 5, using these two variables, please calculate the covariance without using Excel formula for your calculation. So this time, this is asking us to calculate the covariance without using the formula. So I'm just gonna do that here, okay? I'm gonna remove everything. I'm gonna create some space in here. Okay, so first thing I want to do is crime rate minus min. I also need to do expenditure year minus its min. Okay, so it's gonna be this guy minus average, which is, oh, it's way to the right. Here, expenditure 0, 0. This value minus the average of the expenditure. Okay, and then what we do here is product of C and D. Okay, it's going to be product of C and D. Product of C and D. All right. We're just ready. We can just double click. Okay, and we need the sum for the product. Sum of the product, okay? Sum of product, which is going to be sum of E to E, right? And then our covariance is going to be this value divided by, again, I'm going to do count from A to A. This time I'm not going to forget to do -1 because this is a sample data. This is going to be our covariance between A and B. Okay, so let's take a look at whether the Excel formula returns exactly the same result. Maybe wrong, maybe right, but let's take a look. First variable is ranging from A to A. Second variable is going to be ranging from B to B, right? We have a little different result. Let me think about why is this so. I may have made some mistake. I'm not sure which mistake did I made. This is, I think, a very good way to, learn how to use Excel well. This type of mistake you make all the time. So, you see, S3, right? If you click the next cell, it's S4. The mean is drifting. this shouldn't be happening here. You need to absolute reference your mean so that it won't happen, right? Let's do it again here. The same thing happened here. How come I make this goofy mistake? So these two are things you need to adjust. You double click, rest will get adjusted automatically. This is the product of these two. Did I make some other mistake? So it looks like this one was not updated for some reason. Thought I did both of them. Okay, let's do it one more time. Okay, this time it's much, comforting because I'm seeing both of them are the same. Okay, so now you have one result calculated without using the formula, one with the formula. So, most likely in the future you will be calculating this without using the Excel formula, not this inconvenient way of, without using formula, but this is good for educational purpose. Okay, and then can you calculate the correlation coefficient? Correlation coefficient. Yes, of course you can, right? Divided by the standard deviation, sample standard deviation of each one of them. Multiply with this guy. Okay, so this is 0.64. It looks like these are fairly highly correlated. This time I'm doing it using Excel formula approach. Correl A to A, B to B. Boom, exactly same result. So that will do for your homework. Let me see. And then you need to find a way to comment on their relationship, on their direction, and on the magnitude. Okay, for this part, I have explained a lot during the class, so I will just leave that to you. Okay, so that will conclude the homework number 2. I hope you enjoyed it. Let's see how it goes. Thank you.